For our last video, what we're going to do is talk about this last problem from the dividing polynomials set of notes, which is to solve a polynomial equation given one solution to the polynomial equation. So let's look at this one. Here we have this polynomial equation. It's a degree 3 polynomial equation, and it's already been written in standard form for us so that we have all of the non-zero terms over here on the left side and then a 0 on the right side. So we're going to try to apply the technique that we talked about in the previous set of notes, which is the factoring technique. So we want to factor this left side, and then we'll be able to just read off the solutions. Now, we've already been given one solution, so we've been promised that if you plug in -1/3, it is a solution to this equation. So what that means is that -1/3 is a root of this polynomial over here on the left. So maybe let me call this polynomial f of x. What we're told is that f of x, we're told that f evaluated at -1/3 equals 0. But what we saw in the previous video is that if f evaluated at c is equal to 0, that means that f is divisible by x minus c. So in this case, that would be x minus 1/3. So that gives us one factor that we can pull out from f. We know that x plus 1/3 is a factor that we can take away from f. So our first goal in this video is going to be to rewrite the left side of this equation as x plus 1/3 times whatever the other factor of f is. So we just want to figure out what that other factor is. And as usual, whenever you pull out a factor from something, so whenever we pull out this x plus 1/3 factor out of f, the other factor is just going to be the original function f divided by this factor. So in other words, we can divide by this factor to take it away. So if I wanted to compute this factor, the missing factor here, all that I need to do is take f and divide it by x plus 1/3. And to do that, we'll use the ordinary synthetic division approach. So here I put the root on the outside. Whoops, that's a -1/3. So that's what's going to go out here. And with -1/3 on the outside, I can put the coefficients of f on the inside. So those coefficients would be 3, 7, -22, -8. And now we'll do the synthetic division here. So I bring down the first number, that's a 3, and then I multiply by a -1/3 to get a -1 here. Bring down the next number, that would be a 6. Multiply that by -1/3 gives me a -2. If I add those together, I get a -24. If I multiply that by -1/3, what I should get is a +8. And then as expected, what we get is a 0 for our remainder, which is good because that just means that the original f of x is divisible by this thing. And when we do divide f of x by this factor, what we get for the other factor is this quadratic. So we get that f of x, that left side of the original equation, is equal to x plus 1/3, which is what we just took out, times this quadratic. And the quadratic that we get here is 3x squared plus 6x minus 24. So if I go back up to this previous line, that just tells me that our original f of x factors like this. Okay, so now if I take this equation, which we're trying to solve here, x plus 1/3 times 3x squared plus 6x minus 24 equals 0, now I've started to factor this left side. So f of x, which represents the left side of the equation, is equal to this product of these two factors. And now I know that -1/3 is one solution. That's the solution that comes from this left factor. And now I can try to find the solutions that come from this right factor. So in order to do that, what I would recommend doing is you can either use the quadratic formula on this expression, because we know that based on our factoring strategy, we know that either this first factor equals 0 or the second factor equals 0. Whoops, that's a minus 24. So either that first factor equals 0 or the second factor equals 0, and that means that x is equal to negative 1/3, which is the solution we already knew about, or this quadratic is satisfied. So we have 3x squared plus 6x minus 24 equals 0. You could use the quadratic equation here, or you could try that factoring strategy that we've been using for these quadratics, and either one would be fine. I think maybe let's try to factor this, just to get a little more practice with factoring, but it would also be okay to just apply the quadratic formula with this as your a, b, and c values. So if I wanted to factor this instead, what I would do is I would notice that 3 is a common factor, so I can factor out a 3 from all of these terms, and then what would be left over is an x squared plus a 2x, and then minus an 8 equals 0. And then if I divide both sides here by 3, what I would get is x squared plus 2x minus 8 equals 0. And now if I wanted to factor over here, I'm looking for two numbers that multiply to give me negative 8 and that add up to a positive 2. And I do see two of those numbers. I could multiply 4 times negative 2 to get a negative 8, and if I add them up, I get the middle coefficient here. So that means that I could rewrite this left side as x plus 4 times x minus 2. And from this factored form, I can read off all of the solutions. So this means that the solutions to our original equation are negative 1/3, and then I get two more solutions from this factored form. I get a negative 4 and a positive 2. Okay. So those are the three solutions to the original equation that we started with up at the top here. And again, what we're doing really is we're just trying to take this equation and factor it as much as possible. The information that negative 1/3 is a solution allows us to divide out an x plus 1/3, because we know that f evaluated at negative 1/3 is 0. So we can divide out that term, or that factor, and then the remaining factor can be further broken up like we did over here on the right side. And whenever we finish breaking up that factor, we get that f of x, if we wanted to write the full factorization, f of x factors as x plus 1/3 times x plus 4 times x minus 2. There was also a 3 as a factor that we pulled out earlier. So this would be one way of factoring that entire left side of the original equation that we started with. And knowing that this equals 0 means that we can just read off each of the individual roots like we did a second ago. We'll get x is negative 1/3, negative 4, or positive 2. So that's the benefit of breaking up that left side into a product of a bunch of different factors. So again, I'll be posting an alternative set of handwritten notes if you'd like to read through that. I would also recommend for this particular problem that you just read the example that precedes it in the notes, because it's another example that's worked similarly. So I think this is sort of a difficult example because it sort of combines everything that we've been talking about in this section of notes. So make sure that you at least read over those examples carefully to make sure that you're understanding this one.